So basically the VSEPR theory has two fundamental principles, and the first one is that because electrons are all negatively charged, and if you put, for example, the two negatively charged ends of a magnet together, they repel. Electrons act in the same manner, and in nature they repel and they try and get as far away as they can from each other as possible. And it also states that lone pairs have higher repulsion, and this in turn ends up to have a smaller bond angle. So I'm just going to be going and listing just the families of the VSEPR theory and the bond angles related to them. So the first one is linear. And this results in a bond angle of 180 degrees. This is because you have two atoms, basically they're bonded like that. This results in 180 degrees. Now the next one is trigonal planar. And this is when three atoms join and they basically go like this. And if you join it up as a circle, it's evident that 360 divided by 3 is 120, and thus the bond angle of trigonal planar is 120 degrees. However, if you crossed one of these out and made it into a lone pair, this would put higher repulsion towards here, and thus this bond angle will be smaller, and it is approximately 116 degrees if one lone pair. And we call this shape bent or V-shaped. This is because it ends up looking like this. And as you can tell that it's not linear, it's actually bent like that. And if you just put that upside down, it would be a V. Now, the next one is tetrahedral. This is hard to draw, but basically there's one, it's like a tripod stand. I think you get the message. These two are kind of going towards the back, and this is coming towards the front. Oh, I think I can make it kind of 3D. Yep, and that's just basically it. And these bond angles, like an angle from here, that is 109.5 degrees. So 109.5 degrees. With one lone pair, it becomes a trigonal pyramidal shape, and this means that it has 107 degree bond angle. Basically this turns into a lone pair, and you can see that it takes in a shape of a tripod. Now if you add another lone pair, say if you made this one a lone pair also, two lone pairs, it would turn into V-shaped again. V-shaped. And again, these would push just a little bit more onto these, and the bond angle would be 105 degrees. So this shape looks like just like a tripod, like that. And this one looks like There's like 2 on that side, but then there's, oh, it's really hard to draw. And then there's that one. Now, if we move up one, there's trigonal pyramidal. And this is when it kind of starts to get complicated. So basically there is 2 atoms like this, and then through the middle they spark out into 3, if you can tell. So that's going towards the back, that's going towards the front here, that's going towards the front here also. I think that makes sense. Yep, and basically this, now you can see that the bond angle from here is 180 and here is 120. The bond angles are 180 degrees and 120 degrees. Now these atoms are called axial atoms, like the top and the bottom, and the ones with the 120 degrees are called equatorial. I don't know how to spell equatorial. I'm sorry. Now for trigonal pyramidal, when you add lone pairs, the lone pairs always form on the equatorial atoms. So the first lone pair would form, say, here, and that would make it into a seesaw shape. And we just say that the angle is just less than 120 degrees. If we add the second lone pair, it would be here, and that would make it T-shaped. We just say that is more, again, less than 120 degrees. As you can see, it forms a T. Now, if we take the last and final lone pair from here, it becomes linear, and that's 180 degrees because these are all gone. Now they're even, they're just pushing an equal amount of force into each other, and now all that's left is this, so that's just 180 degrees. And last but not least, there is the Octahedral family, and this is drawn like, okay, so again, the axial atoms and the equatorial atoms. Now there's 4 equatorial atoms, and I love the octahedral because every single bond you'll find is 90 degrees. Now, if we took one lone pair, it would be square pyramidal. And for octahedrals, you take lone pairs from the axial ones. So that would make it, I don't know how to, basically, if you can tell, this would be I made that upside down, sorry. But can you tell that it's like a square pyramid almost? That would just be a square pyramid. And this means that these are all now 84.8 degrees, the bond angles. And if I have the last lone pair, that would make it square planar, just like trigonal planar, because they're all in the same plane. Like trigonal planar was just, oh, that doesn't look even at all. Wait, I'll make that even. this meant that they're all just in the same plane, and this is all in the same plane. So trigonal planar, it goes back to having bond angles of, oh my goodness, of having bond angles of 90 degrees. Oh, I'm so sorry. So that just happens to be 90 degrees again, because these are pushing equal repulsion onto them, and it doesn't outweigh any other atoms. So basically, they're just the 5 families of the VSEPR theory, and I hope that helped you revise, or if you wanted to get ahead in class, I hope that helped you understand.